Hello everyone, my name is Karayel and I am studying at İzmir Katip Çelebi University as an electrical and electronics engineering student. In this video, I will present my term project named as Scientific Calculator for Electrical and Electronics Engineering Students for Microprocessors course. I designed and implemented a calculator for electrical and electronics engineering students. The main goal of my project was to design a calculator to perform various mathematical functions and circuit analysis operations commonly used by electrical and electronics engineering students. While working on my project, I used Microc software to code the calculator's functions and Proteus software to observe and control the output of the code I wrote. Before starting the demo, I would like to present you my circuit schematic. As you can see, I chose PIC 18F45K22 microcontroller to operate my project. The reason I chose this microcontroller was because, as we learned about this microcontroller in the lectures, it is easy to understand, program, and provides compatibility with previous projects. I used 30 pins out of 36 pins and 5 ports during the implementation process of this project. Port A and Port C pins are used for GLCD screen connections. For the connection of the solar panel, we used RE4 of port E. We used port B and port D to enable interrupt with help of an AND gate. As GLCD screen, Empire 128 times 64 pixel with KS0108 controller was used to transfer and display our images and functions on higher resolution compared to LCD and other GLCD screens. I used AND gate to control the interrupt pins which were connected on CK. I used potentiometer to provide energy to the GLCD screen. As a power unit, solar panel was used to supply power to our microcontroller. After some researches on the internet, Proteus library for solar panels was found and integrated on the Proteus software. According to the needs of this project, customization of Nikkei pad has been done. Due to the key limitations of the keypads on Proteus library, the new keypad with 9 rows and 5 columns was designed. 10 new functions to analyze electrical and electronic circuit were added. Let's start to test the capabilities of our calculator. On the splash screen, we can see the information about me, such as my name, student number, and my department. I would like to start with basic operations. Addition, subtraction, multiplication, division, square root of a number. We can also do the operations with 3 numbers. Our calculator is also capable to perform trigonometric operations, such as sine. Cosine, tangent, cotangent, arcsine, arccosine. We can continue with logarithmic functions. Log and ln. Besides these functions, we can make complex number conversions with help of our calculator. Polar to rectangular form. X is the real part of our number and y is the imaginary part of our number. We can see the radius and theta values on the display. Rectangular to polar form. We can see the real and imaginary part on the LCD screen. By using angle conversion keys, we can convert from degree to radian and vice versa. Degree to radian. And radian to degree. Now, I want to show you the circuit analysis operations of our calculator. Let's start with series DC circuit analysis. The circuit of the series DC analysis to obtain the source current are given on the PowerPoint slide. According to the given voltage source and resistor values, we can obtain the source current flows through the circuit. Voltage source as 20 volt, resistor as 5 ohm, and we found source current as 4 ampere. For parallel DC circuit analysis, our circuit can be seen on the PowerPoint slide. User can obtain the source current, the current flows through R1 resistor, and the current flows through R2 resistor values according to the R1, R2, and voltage source values. 10 volt as voltage source, 5 ohm as R1, and 2 ohm as R2. As we expected, we found the source current as 7 ampere, I1 as 2 ampere, and I2 as 5 ampere. For series AC circuit analysis, our circuit can be seen on the right side of the screen. User can obtain the source current flows through the circuit according to the given voltage source, resistor, inductor, and capacitor values. The calculator uses these formula to obtain the source current. We found the source current as 5.96 milliampere as we expected. For parallel AC circuit analysis, the circuit can be seen on the slide. Our calculator is capable to solve the equations according to the given values such as voltage source, resistor, inductor, and capacitor values given by user, and gives the source current as an output on the GLCD screen. As we expected, we found the source current as 23,561 ampere. As a new feature, our calculator is capable to perform power and transformer voltage calculations. Our scientific calculator enables users to calculate apparent power according to the given active and reactive power values. When we entered 6 watt as an active power and 8 volt ampere resistor as reactive power, calculator gives us the apparent power on the GLCD screen as 10 volt ampere. Formula of the apparent power calculation was given. Thanks to our calculator, we can also obtain the power factor value according to the real power and apparent power values. Formula of power factor was given in the slide. As we expected, we found the power factor as 0.6. For transformer analysis, when the user enters the primary voltage and secondary to primary turn ratio of the transformer, our calculator gives the result on the display. Primary voltage as 10 volt, turn ratio as 4, and our calculator gave the result as 40 volt on secondary transformer side. EEE edition of our calculator can analyze the diode and BJT circuit easily. The image of the silicon diode circuit and the formula to find the source current was given on the slide. According to the voltage source and resistor values, our calculator can easily find the source current that flows through the diode circuit. 10 volt as voltage source, 9 ohm as the resistor, and calculator displays the result as 1.03 ampere as source current. For BJT circuit analysis, our calculator gives chance to users to obtain collector and emitter current values according to the base current and beta values of the transistor. 10 ampere as base current, 100 as beta value. We found the IC as 10,000 ampere and IE as 1010 ampere. As we have come to the end of my presentation, I would like to thank you for your attention. Have a nice day.